Hi guys, welcome to this set of videos. What we're doing is we're working our way through some shortcuts for proving the congruence of triangles. What we did was we started off this whole idea of proving triangles congruent with this theorem CPCTC. Corresponding pairs of congruent triangles are congruent. But that required us to prove 6 things. We had to prove that all 3 pairs of corresponding sides were congruent, and all 3 pairs of corresponding angles were congruent. And it was a ton of work. Way too much work. So what we were looking at over the last few sections is shortcuts. Some shortcuts, so that we don't have to prove 6 things. So far, we have looked at the side-angle theorem. We've looked at the side-angle-side theorem, the side-side-side theorem, and just in the last section, angle-angle-side theorem. So far we've looked at 4 different theorems, right, that allow us to prove triangles are congruent, but they're shortcuts. We only have to prove 3 pairs of corresponding features in a triangle are congruent. In this one, prove 2 angles and an included side. This one, prove 2 sides and an included angle. In this one, prove all 3 sides. And in this one, prove 2 angles and a non-included side are congruent. If you can do that, that is enough to prove that the triangles are congruent without having to do CPCTC. Proving all 6 things, right? These are our nice little shortcuts. Well, here in this section, we take a look at our last shortcut. And we always start with an essential question. So here's the question we're going to answer. HL. Now, this one might be a little tricky. Up till now, most of you have been able to sort of guess ahead of time what the abbreviations stand for. HL might seem, angle, side, like, what? Okay, here we go. Our objectives, our learning targets. These are the things we're going to talk about, the things you need to be able to do in order to answer our essential questions. So we're going to run through all of these objectives as we go through the notes here together and do some example problems. That way, by the time we get to the end of this set of videos, you should be able to tell me exactly what does the HL triangle congruence theorem tell us about triangles. So let's just jump right into it. Here's what it means. HL simply stands for hypotenuse leg congruence theorem. That's where HL comes from. H from hypotenuse, L from leg. Here's the way it works. What this is saying is if you can prove that the hypotenuse of one triangle is congruent to the hypotenuse of another triangle, and if you can show that one of the legs, and it doesn't have to be this leg, it could also very well be if you could show that these legs are, oh, sorry, I need 3 dashes, I apologize. If you could show that these 2 pairs of corresponding legs are congruent, right? It doesn't matter which pair of legs you show. You just need to be able to show that the hypotenuses are congruent and that a pair of corresponding legs are congruent. Just one pair. Doesn't matter which pair, just a pair of legs are congruent. I'm telling you that that's enough information. Proving those 2 things, the hypotenuses and a pair of legs are congruent, is enough to prove the triangles are congruent. Why? Well, here's the qualifying statement that is ridiculously important. So important. Really important. It only works for right triangles. Must be a right triangle. Well, you guys know what a right triangle is. A right triangle is a triangle that has an angle that's 90 degrees. So as long as you have a triangle with a 90-degree angle in it, this theorem will work. Why? Well, we talked about this one. Take a look at this, right? If I can prove that the hypotenuses are congruent and a pair of corresponding legs are congruent, I already know it has a congruent angle And so essentially what I have here is a side-side angle theorem. We just don't care about the angle because they're already right triangles. I know that they have a pair of 90-degree angles in them. That's given to me. It has to be a right triangle. So we just leave out that angle part. Right, just leave it out. It doesn't matter. And instead of calling it the side-side theorem for right triangles, we call it the hypotenuse leg theorem for right triangles. Again, really, really important. It must be right triangles. So here we go. Let's take a look at a couple of these because I think this theorem's pretty easy to understand. I'm going to go ahead. Let me draw these triangles in two different colors. Here I have triangle W, X, V, and here I have triangle W, X, Y. Now take a look at this. In the diagram, 90-degree angles. I know these are right triangles. So here's what I'm going to try and do. Since I know they're right triangles, if I can prove that the hypotenuses are congruent and a pair of legs are congruent, we're good. We got it. Well, look at what they've already given me. Yeah, they've already given me right here. Boom. That guy right there is congruent to that guy right there. Now the question is side VW and side YX, is that a hypotenuse or a leg? Well, if you guys remember about right triangles, which I know that you do, but I'll just remind you here, in a right triangle, the hypotenuse is always the longest side. In fact, it has to be. That's the definition of a hypotenuse. It is the longest side. It is the side opposite the right angle, right? So if you find in a right triangle, right, find that right angle, the hypotenuse will be opposite that right angle. All you got to do, if you want to, just draw a little arrow, right? It's got to be the side opposite the right angle. That will be the longest side. So here we go. In my diagram, are these legs or are they hypotenuses? Well, since the right angles are up here, that means the hypotenuse has to be the side that is opposite that right angle. Which, oh, look at that. Those arrows are pointing down right there. So I know that that's the hypotenuse side. The question is, can I prove that they're congruent? Absolutely. We've seen this in previous sections. The side WX must be congruent to side XW thanks to the reflexive property. So, I will just put my double hash right there, and cuckoo cuckoo, I know that the hypotenuses of the two triangles are congruent. I was given, right, that the legs, a pair of corresponding legs are congruent, and I know that they're right triangles. So we have everything we need to prove the HL theorem. These two triangles are congruent thanks to the HL theorem. Let's keep going. Got a couple more for you here. Based on what I have in the diagram, I tell you P and R are right angles, which is given in the diagram. I tell you that PS is congruent to RQ, again given to you in the diagram. Can I prove the triangles are congruent? Well, once again, just take a quick look at it. They're right triangles, so the side opposite those right angles are going to be the hypotenuse. Okay, right there. So this is my hypotenuse. Can I prove that that hypotenuse is the same for both triangles? Well, sure enough I can. Once again, the reflexive property tells me QS is congruent to SQ. QS is congruent to SQ, And that's good enough. I know that the hypotenuses of the two triangles are congruent. They already told me that a pair of corresponding legs are congruent. And so once again, HL theorem works. Now, what a fantastic shortcut we've got here, right? Because now we're only having to prove two things. As long as they're right triangles, all I have to do is prove that the hypotenuses are the same and a pair of legs. That's only two things I have to prove in order to show the triangles are congruent. This is a great one. I love this one. Got another one for you here. Let's take a look at what I've been given, and then we'll go from there. All right, they tell me that J and L are right angles, which is given to me in the diagram. Fantastic. They then tell me that point K, oh, there it is right there, point K is, oh, there's another great word. You should remember this from way back in chapter 1. Midpoint means that it is the point exactly in between, right in the middle of two other points. So K is the midpoint of JL. Well, where's line JL? There's line JL right there. And if K is the midpoint, what does that tell me about JL? Well, that tells me that JK must be congruent to KL. JK must be congruent to KL. Has to be. That's what midpoint means. That's the definition of midpoint. K is right in the middle of J and L. But it goes further. K is the midpoint of JL and MN. Well, where's MN? There it is right there. There's MN right there. Now, again, the definition of midpoint. What does it tell me? Well, it tells me that I know that those two segments must be congruent. And K must be congruent to KM. That's the definition of midpoint. If K is the midpoint, it is a point right in the middle of N and M. Great, so there we go. Now, do I have everything I need? Well, again, right, the hypotenuse is the side opposite the right angle. There's my right angle, I go opposite. Yeah, that's definitely the hypotenuse. There's my right angle, I go, yeah, definitely my hypotenuse. So, I know the hypotenuses are congruent. I know a pair of corresponding legs are congruent. We got enough. HL theorem says these two triangles must be congruent. All right, guys, head on over to the next page of the notes. We'll try a few more of these problems together. I'll meet you there.